This is a quick video to show you how to perform structural analysis and design of a simple 2D frame in ETABS software. So what we have here is a 2D frame which has columns separated by a distance of 12 feet and a story height of 10.5 feet. And we have a superimposed dead load of 2 kipper feet. So that's a load besides its self weight. Now let's see how this is performed, how the structural analysis and design is performed in the ETABS software. When you open ETABS, when you create a new file from here, this is what you see. It is a model initialization which has some settings to begin our model with. So I'm going to use built-in settings. And I'm going to use US customary, and we do have SI, MKS, and so on. So we are going to go with the US imperial system. So click OK and move into the quick templates page. Here it allows us to create some grids based on which we can start drawing our members. So we have a number of grid lines. So you have uniform grid spacing in the plan. So in the plan we have X along the X direction. We have assume this is X, and what is going into the plane is Y, and what is the story is in the Z direction. So we have 1, 2, 3, and 4 grids in the X direction, 1 grid in the Y direction, and we have X grid spacing of 12 feet, and this doesn't matter because it is just 1 in the Y direction, so any number will not affect the grid drawing. So in the vertical direction or the story dimensions, the number of stories, so when you look at it, we have, this is not counted as a story, we have 1, 2, and 3 stories. So you have to update this as 3, and the typical story height is 10.5, and we have the option to modify the bottom story height or to give a separate bottom story height, but in our problem we are going to use the same value, that is 10.5. Now once this is done, we can click OK. You can see that by default it is grid only. We're going to use that and click on OK. Now this generates the grid, and you can see that it is generated on 2 windows, a window or 2 windows. This gives a 3D view, and this gives a plan view. If we want, you can see that this has drawn the XY dimensions. We need to see the XZ plane. So let's go into elevation and click on 1, click OK. You can see that it has shown us the elevation view, and 3D is not that necessary in our problem, so we can just close it. And now we have the grid with us. Now let's save the file so that we don't have an issue later. So let's call it example 2D 1. Okay. Once this is done, now let's start defining some of the important characteristics. So before we move on into those, let's quickly review what are here. We can see that there are file, edit, view, define. This is the one that we are going to use to define material properties, section properties, the load patterns, load combination, load cases, and so on. And these are some tools which helps us to start drawing the elements. And you can see that some of these are also given here on the left hand side as some shortcuts. And then we have select. These help us to select particular members. And then this is to assign. Suppose you need to assign loads. This is the one that we use even if we need to assign the foundation type, whether it's fixed pin, are all provided here. This is the tool to analyze. This is the tool to show the deformed shape, display something, hide something, and so on. And this is the design pane, where we have steel frame design, concrete frame design, and all types of design. And this is detailing to show to output the file. And these are some of the units, some general options which can be used, like graphic options, graphic colors, and so on. We do have some plugins which can be added onto ETABS, and this is the documentation. And we do have a model explorer, which we will see in a moment how it works. This actually documents every step that we do here. It is properly documented on the left hand side. So let's, in the first step, start defining some of the materials. Let's define the materials. Let's add a new material. These are some default materials, but let's add a new material. So we are going to use, let's go define concrete first. So the region is US. Let's consider concrete. Let this shape be customary. From that, let it be user, so that we can define the strength and properties. So let's call it concrete 4000, and the material type is concrete. The symmetry type is directional symmetry is isotropic. Can change the color here, which doesn't really matter. And then we can define some of the properties. For example, we gave 4000, which is also the default value, but if we do want to change it to another value, it can be changed right over here. Click on OK, and then we can still modify the material. Like we can give non-linear material properties. We can give material damping properties, time dependent properties such as creep, shrinkage can all be given here, and you can click OK. So that creates the custom or the user defined element. We can also create one more. Let's create a steel for the rebars. Let's call it steel 50, which is 50 ksi, and then we can see that it's steel over here, and the density is all here, and we can change the yield strength, ultimate strength, all from here, which again default value is 50 ksi, so it has appeared to be 50 here. We can change it to any other value as required. Now click on OK. We have two materials. Now click OK. Let's define the section. Now this is where we define the cross sections, the beam cross section, the column cross section, and so on. So what I'm going to do now is we are going to use the same beam for the entire structure, and we are going to use the two different types of columns. One type of column for the between the base and story one, or the ground floor, and then two others for the upper floors, which is of a smaller cross section. So let's create the frame sections. So let's add a new property. Now you can see that we have some default sections which from which we can start. For example, if we click this, we just need to give the width and the depth. In this case, you might have to give the radius. Here you might have to give some other properties like the web details and the flange details and so on. So let's click on concrete. So a new window pops up which has a quick view of your cross section, and then we can call it, say, beam. I'm going to use 8 by 12, 8 inch by 12 inch, and I'm going to use the material that I defined, concrete 4000. You can skip these, but we can change the dimensions if required, or you can add some notes, you can change the color and so on. And it is a concrete rectangular, and the width is the depth is 12 inches and the width is 8 inch. So as we click, you can see that it updates, but there is an important thing that we need to modify or we need to change. That is, you have to go into modify. You have to make it as a beam, because for the design type, if it is a column, we would have chosen this, but for a beam we need to choose this. And for the rebar material, you have to click this. You have to drop down, click on steel, and there are some properties that can be modified, but let's go ahead with the default values, 2.5 inch, 2.5 inch. So this creates our first beam element. Click on the beam cross section, click on OK, and we can see that our the custom section has been added. Let's create the column. So let's call it column 12 by 12. The column material is this one, and this has to be changed to 12 by 12. You can see that it gets updated here. We have to go into modify. This is column, so leave it as it is. And then here we have to again select steel. Okay, now that's it. Click on OK. Again we have to add a new, or you can also create a copy of a previous one, so that you can just need to modify. So column, let's call it 16 by 16. This is 16 by 16. This is a bigger column, and this is column by default. Select steel. Okay. So we have created the cross sections. Now click on OK. Now we need to define the load cases. The load combinations, and so on. So first we need to create the load pattern. So we have some dead load, as well as, according to our problem, we have a dead load and we have a superimposed dead load. The dead load includes the self weight. So we have two cases of dead load. One is the self weight and the other is the superimposed dead load, and we do not have any live loads for the problem. So let's delete this load. Yes, and then let's create a dead load. Let's rename it as self weight and modify. You can see that this has a self weight multiplier, which means you just need to, without adding any loads to it, the software considers the self load in this load pattern. Now let's create another one. Let this be superimposed. So I'll just call it superimposed dead load, and this comes under super dead, and a self multiplier of 0, which means we have to the self weight is not included here, and then click on add new load. So that creates another load pattern. Click on OK. Now we need to define load combinations. Create a new load combination. Let's call it 1.4 dead load, and you know that when we don't have a live load, we have only dead loads, the factor that we multiply it with is 1.4. So let's add the superimposed dead load as well and change the factors to 1.4, 1.4. Okay, click on OK. We need to start assigning our beams to the grid. So let's go into beam, and you can just drag and select. It will assign it to those grid lines, and beams have been assigned very easily. And then to assign the columns, click on 12 12. Let's assign the column onto these, column onto these, columns onto these, and columns onto these. And finally we have column 16, so we can just click and click on this. So we have assigned all the members to the grid lines. Now we need to assign the frame loads. To assign loads onto the structure, we need to click assign frame loads distributed load, and we have to change this to superimposed dead load, and we have a value of 2 kip per feet to be applied. Click apply. Now an error comes that no selected objects were found to receive this assignment, so we need to close this. Select, you can just drag into the beams. Now hold down shift key and select whatever beams is to be assigned, and then go into assign frame loads distributed load, and then you can give a value of 2 kip per feet. This is in case it is a uniform load. Now if it is a trapezoidal load, we do have the option to specify the distributed load. For example, at location 0, it is that is towards the left, that is towards the origin. It starts with, for each member it starts with this point, so you can give a value here. Suppose you have a trapezoidal load which is varying, which is going up, and then at some point it comes down. You can specify 0 and then half a value, another value, and then another value, so you can show the variation of the uniform of the distributed load. Now if you want a uniformly distributed load, you just need to give one value here and click it on apply, and that brings up the value on the screen. Now if we need to change the support type, you just have to select the supports, go into assign, joint, restrain. Now by default it is pin. If you want to change it, if you need a fixed support, you just have to click this and it automatically updates to the fixed support for all. If you need a pin, the assignment, you have to assign it, select it, and then click it. Okay, so it changes to pin back again. Click on OK. Now the next step is to run or perform the structural analysis. So just click, you can just check the model. Click on OK. The model has been checked, no warning messages were generated. That means it is fit for analysis. You can either go through analyze, run analysis, or you have a play button here. Click on the play button. It performs the structural analysis. If we want to see the animation, you can just hit on start animation, which will show you the animation of deformation. Now if you can go into the nodes and see the displacement details, you can see the displacement as well as rotation. It has been, if you need to see more, you can just right click and you can see in a table format. And then suppose you need to see other internal forces such as axial loads, shear forces, bending moments, you need to click on this button. When you click that, we come up with a table with a window where you can specify the load case that you need to see. For example, I need to see from the load combination, I need from the load case, the load combination, I need to see the axial forces or the compression in the columns, or the axial forces in all the members. You can just click on axial force, and you can also click on show values so that we can see the values. Apply. Immediately you see the forces in each column or the axial forces in all members. Suppose you need to see the moment, just click moment 33, apply, and this is the bending moment in each member. If you need to see the shear you can be displayed from here, and okay. So this is pretty much about analysis. Regarding design, we will not go much into design in this video. We'll get into design in the upcoming videos. So let's see what design looks like. Just go into design, concrete frame design, and you have start design. Before that, if we want to see uh, the values or properties of each the internal forces in each members, you can also just go and right click. So that will bring up a window where you can review the deflection, you can review the moment, shear, and whatever is required can be reviewed from here. Done. When you click this, you get back the structure without any displays on it. And then to perform design, go into design, concrete frame design, start design or check. It performs the design immediately because the internal forces have already been calculated. Now it just needs to check with the standards and give us the numbers that is required for the design. Now you can see that it has recommended some areas in terms of inch square. That is, this column requires 2.56 inch square, this requires 1.44, and even along the beam, the variation that the top reinforcement up to this third should be 0.6 inch square, at the bottom it should be 0.3, in the mid span it should be so, and at the other side, at the other end, it should be like this. And this is the basis of design. I hope the basics of ETABS, that too for a 2D, is clear with this video. Thank you.